All right, this number 15 on lesson 3.8. We've got an inverse tangent first. Inverse tangent trig function. We need to take the derivative of. First thing I'd probably do is change this to x squared minus 1 to the half power instead of the square root. So if we're going to do this first derivative right here, our u is our expression. Our u is going to be x squared minus 1 to the half. So our du over dx is going to be the derivative of that. So what rule would I have to use here? Chain rule. So 1/2 times x squared minus 1 to the negative a half times what? 2x. 2x. Yeah. So you multiply by half out front, take that down to negative a half, copy this down, and then multiply by the derivative of that. Let's simplify it a little bit more. Half of 2x would just be x. Move this to the bottom and call it x squared minus 1 to the positive a half. So there's your u that I'm going to plug in. There's your du over dx. So that's just kind of scratch work off to the side. It's going to help me when I go ahead and try to write the answer out. Okay, the formula, I see it's formula B on your sheet, on your formula sheet. It says for inverse tangent, you do 1 over 1 plus u squared. U in this case is x squared minus 1 to the half. So you're going to have x squared minus 1 to the half, and then you're going to have that squared. Times du over dx, which is x over x squared minus 1 to the half. Plus, now I'm going to do the derivative of inverse secant. I guess any questions about this first part before I move on to the next part of the problem? All right, derivative of inverse secant, or inverse cosecant. We don't have a formula for that. But there's an identity that says you can change this into pi halves minus inverse secant of x. So let's do that. Let's change inverse cosecant to pi halves minus inverse secant. So the derivative of pi halves is going to be 0 minus the derivative of inverse secant is 1 over absolute value of u. Now, u is no longer this big expression here. Now that we're on this second part here, u is just equal to x. So it's going to be the absolute value of x times the square root of x squared minus 1 times the derivative of x, which would be 1. So on this second part of the problem, my u equals x. My derivative of u with respect to x would just be 1. So you have to kind of keep that straight, that this scratch work only applies to this first part of the problem. The second part of the problem, I'm going to use these values. Now if I know that x is greater than 1, I know it's a positive number. Do absolute values have any effect on positive numbers? No. So you could take off this absolute value if you wanted to. I don't know if the book does or not, but since you know it's positive, you don't need to have an absolute value there. Now let's try to simplify this. Not too far from being done, I don't think. If you square a half power, what's going to happen right there? You're going to get 1. Half times 2 is 1. So you're just going to get x squared minus 1 there. Times x over x squared minus 1 to the half minus 1 over x. I'm going to rewrite that as x squared minus 1 to the half. So that square root I changed to a half power. I just try to get them all to match, kind of. So let's see. This 1 and this negative 1 would cancel. Right? 1 minus 1, these would cancel. And so basically here I have dy over dx equals 1 times x, which is x, over x squared times, I'm just combining this all into one fraction, just multiplying straight across, over x squared minus 1 to the half, minus 1 over x times x squared minus 1 to the half. here with these x's. Yeah, this x could cancel with one of these x's. I couldn't cancel here because there's a minus right here. I couldn't cancel these x's because of the minus, but I could cancel here because this is multiplication. So if I did that, if I took an x out of, right now there's a 1 there, if I factored up this x and canceled an x here, so this is x to the first, now what would you notice about this fraction and this fraction? They're the same exact fraction. They're identical. When you subtract two things that are identical, what's the answer? 0, yeah. After all that work, our derivative is 0. Okay? Everything canceled out. All right, I think that's enough for 3.8 today. If you still have questions on it, I think there's only so much of this stuff. I mean, maybe some of you really like it, but to me, this is my least favorite stuff to do. So I'm going to move on to something different. Let's move on to lesson 3.9, and I'm going to show you